All right. Hey, good morning, everybody. As we get started, just to let you know, there's some functionality to be aware of as well. Right now, everybody is muted on the call, but you will have an opportunity to ask questions over on the right-hand bar. There's a place to type in a question. As we go along, if we see questions, we'll try to answer them as we go, or maybe at the end we'll gather them up and go through them as well. But this webinar is about you, and it's really intended to make sure that we answer your questions. So don't be afraid to type in your questions, and we'll make sure we try to get them handled. So with that, let's dive in and start the call. There we go. Quick, let's review what we're going to talk about. Really, we're going to spend a little bit of time, not as much time, on the sampling procedure. How do I interpret the results? And then also, what about pH? That question has come up quite a bit. When we think about how to sample, really it's the where, when, and how. We'll spend a little bit of time talking about where we should pull samples, when's the best time to sample, and then also how should you sample, what depth, how many probes per sample, and then how to handle the sample once we pull it. Then really where we want to spend more time today, I think, is interpreting those results. I think it's important to understand that it really is art and science both, and it takes some knowledge and understanding about nitrogen conversion. So we want to be able to make sure we understand what's going on in the soil to help interpret the results. Do the results make sense? Utilizing that in calculator, and then also deciding, hey, am I on track? Have I incurred losses? Is there a yellow light? Do I need to go back and sample? Those are some of the things we're going to talk about today. So let's start off really with where should I sample? When you think about where to sample, I guess the first thing I would say is to remember that this is a decision process. So we're not trying to grid sample and understand what's going on in every acre and a half or 2.5 acre grid. We're really trying to make decisions about how do I apply my nitrogen. One of the things I would tell you as you think about sampling is that consistency and accuracy of sampling are absolutely critical. I get the question a lot as we talk about the SOILSCAN of, how accurate is it, how repeatable are the results. And I would tell you my experience would indicate that we get more error as it relates to sampling and sampling procedures than you'll ever get from the machine. So make sure that you're doing your sampling procedures correctly, that it's repeatable, so that we eliminate that part of the error in that part of the process. Then the other thing as you think about where to sample is to know how you're going to apply your nitrogen. Are you going to use a variable rate or a flat rate? Obviously, a variable rate is going to require you to take more samples because you need a higher fidelity of data to make decisions and to create your VR map. So it's important to understand how you apply your nitrogen will determine a little bit how you're going to sample. Let's say we have this field here and we're not going to variable rate this field. Here's how I would do it. And I put a couple X's in here, but if it's me, I'm going to look at the main area of that field and I put 2 X's, maybe I put a third X in there as well. I'm going to go to those spots and I'm going to pull samples from at least 2, 3, maybe 4 different spots in the dark green area. And in that light green area, maybe I'll pull a sample once from the part in the upper right part of the field, and then once down low, maybe 1 or 2 samples. But it's important to understand, again, if this is just a flat rate application, I'm trying to understand what's going on in the field. So I don't need to go out and pull, again, a grid sample kind of pattern. And we'll talk a little bit about interpreting the results. If once we pull these samples and we get results that we think make sense, that's probably enough data. Now, if I'm going to grid sample or if I'm going to variable rate a field, then that's going to require a higher fidelity of data. So in that case, I think I would go out and sample more intensely to make sure that you understand those areas that are going to be applied. You're going to apply the N differently. Make sure you understand them better so that you can create those VR maps in a way that is going to create, again, better data set to apply your N. Yes, you know what? That's a lot of work, but the return in the end as it relates to the yield and the nitrogen application is going to be greater. So it does require more sampling, but the reward in the end is going to be, hopefully, you have 2 goals. I was sharing with somebody the other day. The goal is either, maybe get more yield with the same N, or even you may find in some cases you'll get the same yield with less N, but applying it more accurately across the field. So as we go into where to sample, the next thing you need to understand, and this is as we're kind of zeroing in down on more of a microclimate. We talked about where in the field, how about where across the row? You really need to understand where your N was applied. If it's banded in the row somewhere, that's going to require more intense sampling across that row because you want to make sure you get a representative sample. You don't want to pull a probe from a hot spot and use that as your data point. I typically use a sampling board. We'll show you a picture here in a minute. And I go out and sample pretty aggressively across that row, and then I blend and create a composite sample to use when there's banding. If there's broadcast in that field, the guy spread urea, or his only application up to that point may be, say it's 30 gallon in a weed and feed or something like that. In theory, that's more uniform distribution. So you would still probably want to sample across the row, but you don't have to sample as intensively across that row because, again, in theory, the N distribution is a little more uniform. So maybe not quite the number of cores across the row. We'll show you a picture here to illustrate that. This was actually a study from the Iowa Soybean Association, and this is a good illustration. This is obviously between the two rows, and what they did is they went and sampled every 3 inches. They started in the center of the row, and then they pulled cores every 3 inches all the way across that row. This is an example of where anhydrous was applied in the middle of the row. This is the kind of sampling procedure they used to pull their sample, and here's why. Here's the data that they found. This is in 2015 from last year as they did their sampling, and what you can see is even 4 weeks after the application, the chart on the left is 150 pounds, chart on the right is 100 pounds. But the important point here is if you look at that those graphs, what it indicates is the vast majority of that nitrogen has remained 4 weeks after application right in the center of the row. So, excuse me, as it relates to sampling procedure, you want to make sure you want to sample in that row, but you also want to sample across that row, blend a composite sample so that you're making sure you are getting a representative sample of what that corn plant may see. Yes, that requires more work, but we have to have that accuracy in the sampling. So if the results that you pull make sense, and we'll talk about this as we get into making a decision later, then maybe you don't need to go out and pull more samples in a field. A lot of times, though, if I'm in a field and I pull some samples and I see that maybe it doesn't make sense, then I may go out into that same field and pull a few more samples, come back and test them just to make sure to kind of validate what I'm seeing. And we'll talk about that when we talk about interpreting the results. But let's say, for instance, a field has 3 zones and you're going to flat rate it. I typically go 2 of those zones, maybe the high zone and the low zone, pull my samples, look at the results, and if it makes sense and I can make a decision off what I see, I'm done. If, however, I'm not sure, or I look at the results and it's not clear to me, I may go out and pull a few more samples in that field to help me make better decisions. So, hope that makes sense. So then the next question is, when do you sample? And I get this question a lot, actually. I was with a customer the other day and was wanting to know if he could start sampling right at planting. And my answer was really, one of the big benefits of the SOILSCAN machine is that it allows you to collect data close to the time of decision. So what I tell guys is, hey, go out in that field the same day, the morning of, the day before that you are going to make your nitrogen application, and pull your cores in, if you can, to make your decision. It really reduces the likelihood of sample variability from the handling, and it allows you to, again, have that decision as close to the time that you pulled the cores. So I'll give you a great example. We had Ron Lloyd and I this past summer in 2015 were doing a field day in North Dakota. Many of you have heard me tell this story, and we pulled these cores, put them in a bucket, and the sun beat down on them, and we'd introduced a lot of oxygen, so we were mineralizing a lot of nitrogen from the organic matter. In the morning, some of those samples were testing like 9, 10, 12 parts per million. But by the end of the day, because they sat in a bucket and the sun had hit them and the oxygen had got on it, and we started mineralizing a lot of organic matter, by the end of the day, they were testing in the 20s, 20 parts per million of the same sample just sitting in a bucket. Because, again, we'd warmed the sample, we'd introduced oxygen, we were mineralizing organic matter. So that's why I say you should really run your samples, test them quickly. That's the benefit of the SOILSCAN machine, because the difference between that and throwing them in a soil test bag and throwing them in the bed of your pickup or on the dash of your cab, it can really affect the results you find. So test it as soon as you pull it if you can, and then test it as close to the time of application that you can as well. So how do you sample? Remember, what we're trying to learn is what's available to my plant. Where is that in my soil profile? What form is it currently in? And then how do the results affect my plants? All three of these things really would impact how you pull your samples. For the most part, we're going to recommend a 12-inch sample. Having said that, there's going to be situations, maybe out here in Illinois where they have a deeper A and B horizon. Maybe in those situations, and depending on the rainfall, we may take a 12 to 24-inch sample. All right, there may be some situations where we split our samples. For instance, one of the things you have to understand is what form you used, how long ago you applied your N, and what's the weather been like since you applied. Here's an example that I use. This is a real life situation. Last year, I had this example in West Central Ohio. The grower had applied 28%. He hadn't had much rain at all, and I think it had been about 2.5 weeks since he had applied the M, and he was ready to come out and do his first side dress. So he said, "Hey, let's take some samples and let's make some decisions." And typically, again, I will take a 12-inch sample, but in this case, because he'd applied 28% on top, he hadn't really worked it in. He hadn't had a lot of rain to move it. What I wanted to know was where the N was and what form it was in. So I actually pulled 12-inch cores, but I broke a number of them up, 0 to 6 and 6 to 12. And then I tested them separately. Then I also created a composite sample and tested them together. And the reason I did that is I was trying to understand how much that N has moved, okay? And then also what part of that, how much of it had converted. There may be cases where you have a year like last year when you have 12 or 14 inches of rain in June. You may want to go pull a 0 to 12-inch core. Then you may want to go get your son or somebody big and strong, have them go down the same hole and pull a 12 to 24-inch core to see how much depth, what depth some of that nitrogen may be, because it will help tell the story and you create a picture that explains movement, conversion at the same time. Okay, now, those of you in the East, I know that picture on the left is not necessarily reality. But on these loamy soils, that's a great, we'll call that aspirational goal. Really, you want to grind that soil up as much as possible, create the fine particulates, because we're trying to extract nitrates from the soil. So the finer we can get the soil ground up, the better off we'll be. I get this question a lot. Should I use a blender? Can I do something like that? And the answer is yeah, you can use a blender. Some of the guys, some of the Rams, they use a Ninja blender. That's fine. What we don't want is samples like over on the right, because if we try to test those, we're not going to be able to extract the nitrate nitrogen out of that soil as well, and the results that we get will not be representative of what's happening in the field. And again, remember, we talked about sampling procedures impacting the results. This is really a good example of that. You really have to make sure you get that sample as fine as you can, blend it as well as you can to make sure the data we get is good. Okay, this really explains what we just talked about. Don't wait to run the samples. And again, that gets back to that story I shared about this last summer and the mineralization of the organic component of your soil. That's why we don't want you to wait. But if you are going to wait, make sure you get those samples on ice. Make sure if it's going to be a couple days or 3 days, let's get them frozen. And the reason we do that is once we get that soil cooled down below 50 degrees at least, the mineralization of the organic portion drops way, way down. That's why we would want you to do that. Otherwise, use the machine the way it's intended, which is pull the sample, run the sample right away. Okay, I'm going to jump over now to the question that really pops up the most, and that's, hey, I went out to the field, I pulled the cores, and I got this number, and the number says 12, but what's that mean? What do I do with that? And really, this is where the art is critical to join with the science. And the art part is understanding nitrogen in your soils, understanding the conversion process, because it's important to know that the SOILSCAN 360 SOILSCAN machine today is a nitrate testing machine. But your soils oftentimes, depending on the form you've used, depending on how long ago you put your nitrogen on, will also have ammonium form nitrogen. So we have to understand that as we use the machine to help make recommendations to our growers. Many of the local universities in the Midwest will have a conversion table. I'll show you a couple different ones, but what you'll notice when you look at them is they vary. And that has to do with drainage to a certain degree, with the components of the soil, sand, silt, clay. It has to do with a lot of things. Remember, many of you have been through some of the training. We talk about the conversion of nitrogen in the soil as a biological process. So things like temperature, moisture, oxygen, pH, residue levels, drainage, those things all impact the conversion of nitrogen in your soil. So it's not a perfect equation, but you just have to understand that art when we have discussions with our customers about the results we're seeing. So let's dig in. Here's a couple different tables. I want to show you two. This one, this is a newer adapted chart. And if you look at it, it's kind of interesting. That gray bar across the top is 0, 3, and 6 weeks. In other words, that's how long the nitrogen has been in the soil. Down the left side is the different source of nitrogen. And then in the columns, basically what those columns are saying is how much of that nitrogen is in the nitrate form. So let's use an example. UAN, 3 weeks after you apply it. Now again, remember, this is a biological process we're talking about. Truthfully, I would prefer ranges because it's not a hard, fast number like this, because temperature, moisture, oxygen, pH, residue can all impact this process. But in this chart, all right, they're saying that 3 weeks after I apply 28%, about 60% of that total nitrogen should be in the nitrate form. Now, it's important to understand, as we're out pulling soil samples for a customer and running them through SOILSCAN, we need to know that number so that we can understand how much is in the nitrate form and how much might still be in the ammonium form, okay? Let me show you another chart. This is actually the next chart. This is the one I probably use more. This is adapted from the University of Illinois. And interestingly, it has kind of a different set of numbers, all right? So it's got 2 weeks and 4 weeks. What this chart would tell you is it probably has a quicker conversion. But if you looked at that same UAN solution down at the bottom and a spring application, 4 weeks after you put that nitrogen at 28% on the field, okay, in this chart, they're saying around 85% of that total N. So let's say, let me give you an example. Let's say you put on 30 gallons of 28%, all right, and you put it, so that's 90 pounds. This chart would say about 4 weeks after you put that on, all right, about 85% of it is in the nitrate form. Let's look at, for instance, anhydrous ammonia. Anhydrous, applied in the spring, unstabilized, that'd be the middle row. 4 to 5 weeks after you put it on, 3/4 plus of that anhydrous has been converted to the nitrate form, okay? Again, just keep in mind, it's a biological process, so a lot of things can drive that faster or slower. So that's where the art comes in with the science. So let's work through a couple of real life examples to help you as you go out and make a call. So at planting, let's say the grower applied 20 gallons of 28%. Okay, it's in a corn bean rotation, and he worked it in. It's about 3.5% organic matter. It's a prairie type soil. He did it about, say, a little over 3 weeks ago, He's had real steady rainfall, nothing dramatic, no ponding, and the temperature's been fairly normal. Good warmth, not too cold, not too warm. So the first thing, and the grower says, hey, I want you to come out and run a soil scan because I'm trying to do my first side dress application, all right? So in my opinion, the first thing you have to do is say, all right, do you believe the grower's experienced a lot of denitrification, volatilization, or leaching, all right? In this case, I don't really think so. He's not, probably with 3 inches of rain, he's probably not leached a lot. He didn't have any real heavy rainfalls where his soils got saturated, so he probably didn't denitrify a lot. He's probably had a pretty standard kind of growing season. So we said it was 28%. All right, so let's work through this part. UAN solution, and it was 22 days. So I'm going to use that 3 week. In this case, I can use this one. You can use another chart. But I'm going to say because he's had good temperatures, likely good aeration because he didn't have any toad drowners, all right? I'm going to say about 65%. It says 60. I'm going to use a little higher number. And I'm going to say about 60 to 65% of that nitrogen, that 28% he applied, is in the nitrate form, okay? So based on the information that we got from this grower, based on what he told us, how much nitrate would you expect to find in that sample? Let's work it through, okay? And by the way, I'm going to stop real quick. The question has popped up, will this deck be posted? We're recording this. This deck will be posted. You'll have access to this information, okay? So the grower put on 60 pounds. He probably didn't have a lot of loss. And given that he's had good aeration, okay, fairly normal temperatures and good moisture, you should expect some mineralization, whether that number's 10 pounds, 12 pounds, 15. There's some mineralization that has occurred. Now, when that's mineralized, it comes first in the ammonium form, okay, and then gets converted. But based on what I know, I'm going to say because he's had 3 inches of rain and it's a 3.5-inch prairie soil, I'm going to pull a 12-inch sample because this crop's growing rapidly right now, and I want to know what's there for that root system to access. Because it's not banded, I'm going to pull 3 or 4 samples across the row, and I doubt there's been excessive loss. All right, so 60 pounds at about a 60% conversion rate. Remember that chart, all right? Should be about 36 pounds of nitrate, and there's probably a few pounds that have come in through mineralization. But keep in mind the crop has taken some up as well, all right? So in my mind, as I look at that, before I go pull a sample, I know I should probably find somewhere in the neighborhood of around 40 pounds of nitrate. Could be 35, could be 45, but I should find somewhere in that neighborhood of 40 pounds of nitrate in my soil. So knowing that, when I pull a 12-inch sample, what number should I expect to find? Well, let's keep in mind a 12-inch sample is, in essence, I'm using round numbers. It's not exact, but I'm going to use round numbers, keep it safe here, keep it easy for me. A 12-inch sample is basically 2 acre furrow slices. So it's around 4 million pounds of soil, right? So if I get a soil scan reading of 40, all right, I want to convert that to parts per million. I want to convert that parts per million to pounds, right? I'm going to divide by 4. So if I get weather, go through and you think about, okay, the weather, the conversion, I should expect a soil scan number somewhere around 10 parts per million, because to convert that to pounds, all right, it's going to be times 4. That would be around 40 pounds, okay? So therefore, my soil scan reading should be somewhere in that 8 to 12 part per million range, okay? So let's go farther. So I took 2 samples in the dark ground and I took 2 samples in the light ground. And in the dark ground, the samples, let's say as I pulled those samples, I can't read it. Oh, 12 to 14, sorry. And on the light ground, the 2 composite samples read 9 and 10. All right. So based on what we found, I have 3 questions. Number 1, do you believe the samples to be fairly good samples? Okay, in this case, I would say yes. Because remember I said we should find around somewhere in that, 35 to 45 pounds of nitrogen. And remember, to get a pound, you multiply parts per million times 4, because it was 4 million pounds of soil in a 12-inch sample. So yeah, on the dark ground, I would expect a little higher number because I probably mineralized a little bit more. And on the light ground, I'd expect a little lower number. So yeah, to start off with, I believe as I pulled these samples, I probably got fairly good samples, and I don't think I need to go back and pull many more cores from this field. The second question is, what would I recommend to the grower based on what I found? Well, in this case, and this was, again, a real-life situation for me last year, what I told the grower was, hey, you're right on target. You've not lost a lot, okay? You've not denitrified a lot. So as you develop your nitrogen application, your side dress rate, based on what we know and what we found, Mr. Grower, you're on track. You don't need to augment to compensate for losses. You don't need to really compensate for leaching. You need to just stay on track with the program that you developed. Now, the third question, though, is that's okay, it must have disappeared on me. The third question is, as you run the in calculator, okay, as you run the in calculator on that particular field, what are you going to tell that grower as it relates to ammonium nitrogen, okay? What you're going to tell him, remember, he applied 60 pounds in that situation, and we said about 60% of it had converted. So keep in mind, 60 minus 36, 24 pounds. When you run the in calculator for that grower, you just need to be able to tell him, hey, just keep in mind, there's somewhere in the neighborhood of 20 to 25 pounds of nitrogen in this field in the ammonium form. So as you do your side dress application, make sure you account for that ammonium nitrogen. And because that soil scan is telling you nitrate nitrogen. So just understand that when we did that initial calculation, all right, there was 20 to 25 pounds still in the ammonium form. So when you do run the in calculator, make sure you account for that. Okay? All right, let's do one more quick example to explore this a little bit. In this case, the grower applied a 120-pound base rate of anhydrous, unstabilized on April 15th. And he threw in an extra 10 pounds in the starter. He planted around May 1st. So a couple weeks after he applied, he planted. And he's ready to apply his first side dress application using a wide drop side dress system. It's about V5 or V6. Today's date, let's just say it's early June. Now, the weather was really cold through the end of April, and then a warm front came through, and it's been really nice since the beginning of May, okay? I'm going to go sample at a 12-inch depth, and I want to run my soil scan results. Well, let's walk this through, all right? So I'm going to assume that since it was pretty cold early on and then warmed up, that my anhydrous converted at about 75 to 80%. Now, that number came from those charts I showed you. Every university has their own chart, but it's been around that. I'm going to use 4 to 6 weeks, but because those first 2 weeks were really, really cold, I'm going to use the lower end of that. I'm not going to the high end of a range there. So I'm going to say 3/4 of it is converted to nitrate. All right. So of that 120 pounds of anhydrous, about 80%, 75 or 80% of it's converted. That's around 96 pounds. All right. They should be in the nitrate form. Plus you probably had a little bit mineralized, and there's a little bit in the starter. So maybe in that 100-pound range. That's in my mind as I go to this field. That's what I think I should find, okay? Now, you go out, the grower asks you, and let's just say for argument's sake, this is a fairly uniform field. You run your soil scan results, and they come back with a reading of 14 parts per million. Now, my question is, what would you tell this grower? What would you do? Well, in this case, if I take a 12-inch sample, I have to multiply that by 4. Okay, so what is that, 56 pounds? In this case, I found 56 pounds of nitrate in a sample that, if you look above, okay, in theory, I should have found somewhere in that 100-pound range, and I found 56 pounds. So in this example, I'm going to do one of two things. Either I'm going to question the sample I took, but before I do that, I'm going to ask the grower, hey, tell me about the weather here, all right? And this, again, was a real-life example. And what I found out when I asked the grower, he goes, oh, yeah, he goes, we had about 4.5 inch rain. And he said, my soils were just waterlogged for about 4 or 5 days. Well, there's charts available that you can go on. I think I may have included one in this deck, actually, to calculate, to understand, once that nitrogen's in the nitrate form, how much of it can be either leached or denitrified, converted to gaseous form and lost. All right? So in this case, when I had the conversation with the grower, he said, oh, yeah, he said, I had about a 4.5 inch rain. And it was like a week ago, so I had converted maybe 70% of it. And in my opinion, the grower had lost a good chunk of nitrogen, looking at that chart, that denitrification chart, probably around 40%. So here, this number made sense, right? Because if I take 40% of 100 pounds, he should have in that neighborhood of around 60 pounds, and I found 56 pounds. So I don't have to go back and take more samples. I did have to ask more questions to find out why that number was what it is. And then when you go run the nitrogen calculator, again, you have to understand now that nitrogen calculator is going to be making the calculation that there has been some loss. It will help calculate the correct amount, and just understand that there's maybe another 15 or 20 pounds of ammonium form, but this grower has lost nitrogen. And in this case, the nitrogen calculator will compensate for that, because it's understanding, it's reading the real number, and you'll be able to make a recommendation that will compensate for it. But just know also there's still a little bit left in the ammonium form. That's two really real-life examples. It varies. This is, by the way, the tables I used when we talked about. There's the conversion rate, and then I think the next one is the loss rate. Here's that loss rate, right? So in this case, it warmed up. So you have two different soil temperatures, and he said his soils were waterlogged for, 3 days, I think it was. So I used about a 60% number. All right. So that's again, use the art with the science to help understand the losses. Let me give you a good example here. If you have a real poorly drained heavy clay soil, you're probably going to go to the higher end of that range. If you have a high organic matter, well-drained silt loam, you're going to go to the lower end of this range, because those things all impact this process. But just know that you can use these charts to help the art with the science to make those decisions. So that's how I used the data, used the SOILSCAN machine to help make decisions for both those growers last year. So last, we get this question a lot about pH. Why do I need a pH sensor? Is it important? How should I use it? Well, I'll give you a couple reasons here. Number one, and as you think about pH, keep in mind we're measuring the water pH, the pH of the water in the soil, and it's critically important to understand pH because that helps determine the solubility of nutrients in your soil and the availability for plant uptake. So, for instance, if I had some spots in a soybean field, let's say it's a low, real high organic, dark area, and I'm seeing in my soybeans some interveinal chlorosis, dark green veins, okay? In my mind, I'm probably suspecting a manganese deficiency. So if I go out and I pull some cores and I test for pH and I find a pH of 8 or 8.2, that's going to confirm what I'm seeing. And in that case, I may go to that field and do a foliar application to help rectify the situation. So you can use the pH meter to help understand if you have nutrient deficiency issues or micro issues in that field. There's some other ways to use it as well. You have to understand that pH is important in the degradation of herbicides. So if you're seeing areas of injury, all right, maybe you go out and pull some samples, measure the pH. You may learn about carryover issues. You may learn about degradation issues of the herbicide. You can also understand that mineralization of organic matter decreases pretty dramatically as pH declines. So it also impacts the conversion of nitrogen. All right, pH imbalances also dramatically impact biological and enzymatic activity in your soils. I pulled this chart and threw it in here, but it shows the different ranges for bacteria, fungi, things like that, to help you understand that if you're seeing weird things in your field, pH is a great place to start. So you can go out in the field, use a pH meter, test for it, and maybe that'll help explain some of the things you're seeing. So I would use the pH sensor as a diagnostic tool to help understand some of the issues that could be cropping up in your field. Do you have weedy spots? Do you have areas in the field where the crops just never seem to look right? That's when the pH meter is a great tool to help diagnose some of these issues, okay? One thing I would tell you is keep in mind that you can go a 6-inch sample depth, you can go 6 to 12. I put recommend 6-inch. That's an acre furrow slice. That's a great place to start. The one thing I would tell you is as you get into no-till, oftentimes if you're not ever tilling in a long-term situation, you're spreading your lime on top. In that case, you may see some pH stratification, and so I would recommend there's no harm in splitting your sample to learn if you're seeing any pH stratification, because that might impact what you're seeing as well. One other thing I will say, as you think about pH meter is, it's the water pH. In order to understand how much lime to apply, we still have to come back with buffer pH. But that pH meter is a great tool. It's a great diagnostic tool to help understand what's going on in your fields, especially if you have spots where you just can't seem to grow the crop or it's weedy or something like that. It's a great tool for that. So with that, I'm going to stop. And I think, I guess we'll go, let's do this. Let's check and see if there's any questions. So one question is, do different types of inhibitors affect the conversion of the nitrate differently? Okay, great question. And there is, I think we actually have a presentation up online somewhere. I have to look on nitrification inhibitors. I'm sorry, let me rephrase that. Nitrogen inhibitors. They're really, and this is a whole nother presentation, maybe we should do this sometimes. What you need to understand is you have urease inhibitors, and then you have nitrification inhibitors, okay? So a urease inhibitor is something you would use with urea form, so at UAN solutions, urea. The goal of a urease inhibitor is to stop the conversion, all right, of that to the ammonia form, because that ammonia form can be lost to gas before we get it in contact with the soil. So we would use a urease inhibitor to give us basically the goal is to give us 10 days to 2 weeks to get that urea form nitrogen in contact with soil, so that when it converts to that ammonia form first, it quickly becomes ammonium and is held by the soil. So that's what a urease inhibitor does. It's urea form. It stops the urease enzyme. In essence, it gives us another 10 days to 2 weeks to get a rainfall, get moisture, to get that urea in contact with the soil, so that as it converts, the first step as it converts to ammonia, you want that to occur in the soil so it grabs the hydrogen from water and becomes ammonium and is held by the soil. The other type of inhibitor is called a nitrification inhibitor. Nitrification inhibitors, all right, for the most part, there's a number of different ones. They do different things. There's DCD and nitropyrin. They basically they are killing off the bacteria that convert the ammonium to nitrate, and so they will slow that process down. And again, it takes a while for that bacteria to repopulate in your field. So, and again, it depends, right? It depends on how the type of soil, the oxygen, the moisture, the temperatures, but those bacteria have to repopulate in order to convert over to nitrate. So yeah, depending on the nitrification inhibitor you use, it can slow that process down. And in those tables I showed you, it actually had, for instance, stabilized anhydrous versus unstabilized. So long-winded answer. That's probably, I will come back to you, and maybe we need to have a webinar sometime about nitrification inhibitors as well. It's a good question. Is there a way to make an educated guess on organic matter? You know what? Here's what I would tell you. If you've been in there, you can find that on mini soil tests. Again, it's imperfect, but even the conversion of organic matter and getting nitrogen is an educated guess. But I guess it's experience, it's time, it's understanding the soil tests. You can find that on soil tests. There is, but it's based on color, organic matter, So it's, I guess, experience is the best teacher. It's hard to answer that, but there again, you can find that on a lot of soil tests. Okay, using university charts, are there any charts converted to metric? The short answer to that is I'm not sure. I would think some of the folks in Canada may have those. It probably wouldn't be too hard to convert them to metrics from a pounds per acre to I guess it's kilograms per hectare. Oh, is it Russia? Okay, so we can try to find some of those, or maybe even convert them ourselves for you. How do you recommend pricing custom sample processing? It's a great question. This came up on a call I made on Monday. The truth of the matter is, it's up to you. I have guys do different things. I have some guys who will go out to the field. They'll pull the samples, and basically what they'll do is they'll go out and they'll charge maybe a $25 or $50 fee to go to the farm. And then for every sample that they pull and test, they charge like $15. All right. If some guys, they'll set up they will set up a SOILSCAN machine in their shop. They'll say, hey, on this day, I'm going to have a SOILSCAN day. Go pull your cores, bring to me. In that case, they may charge $7 or $8 or $10 or $5 or whatever. It's kind of up to you. But there's different opportunities to do that. So that's a different way. Again, some guys charge a fee to go to the farm, and then if they're pulling the samples, obviously they're charging more. What solution should we use this season for the SOILSCAN, last year's leftover? Here's what I would tell you. It's not that expensive to replace that bottle. I guess I'll tell you what I did. I threw mine out and got new solution and a new sample because it'd ridden in my truck. And I don't know, it's $15 or $16 a bottle and especially if you've added the pH sensor, then you definitely need the new solution. But I got a new bottle and started over. Would the same be true for fall applied hog manure? The answer is no. And manure is obviously it's common on a lot of farms. Manure mineralizes, and this kind of is a whole nother discussion as well. But it mineralizes completely differently than inorganic forms of N. It is more stable, and it mineralizes over the course of the growing season. So to be really candid, predicting manure mineralization is harder. I guess what I would tell you, I wish I had a whiteboard I could draw. What I would tell you is it's not, a straight line relationship. It has a lot to do with that biological process we talked about. But what I would tell you is it is more stable across the growing season. And it is hard to predict, and that's something I think we need to work on, but it is not as easy to predict. What about taking tile water readings now? Basically, I would tell you that we are still beta. Are we testing those tips, the new water tips?
The new release has pH water.
Okay, so yeah, you can do that now with the new T. Okay, there you go, can do it. How much conversion have there been this season from fall applied? You know what? We're going to send out a blog here really, really soon. But because we had that really warm fall, in fact, I think November, December were record warmth in some of these fields run. It was how much conversion this from fall applied in. I think in some cases we're finding 50 or 60% conversion already, aren't we, of the anhydrous?
Yeah, I think there were some samples that were that high.
Yep. So, and again, a lot of that depends on what happens between now and planting. But we should have a blog out on that pretty soon. You stated that we can only test nitrate in currently. When do we think we will have ammonium? John, comment on that?
It's still in test. It's an early test, solid results, but don't have a timeline when it's going to be available yet.
Okay, we're bumping up against on time. There's two more questions here. Can you adjust the amount of nitrogen used per bushel? Example, 1.1 pounds of units per bushel yield goal. So it's a great question. Here's what we know, right? We know that when we measure the nitrogen that's in the stover and the grain, that plant needs 1.1 pounds of nitrogen to produce that bushel of grain total. The goal for what we're doing, and again, I had this conversation on Monday where the grower was, all right, is to be able to apply, all right, less goal. And I said, this is aspirational goal, is to be able to apply less in order to reach that yield. Okay. In other words, Greg, and I think this is right, Jim, I think Greg's goal is to get that 0.6 or 0.7 applied in order to reach applied per bushel in order to reach his yield goal, because he's going to split apply, he's going to spoon feed, and therefore the losses are less. All right, and he's going to count on mineralization. He's going to count on some of these different forms, all right, and his rotation, things like that. So that the goal is, to really be able to be more efficient. Here's what I would tell you. There are some years, like last year, for instance, in the East, we probably needed to apply 1.3 or 1.4 pounds in order to get a bushel of corn. There are some years when you have wonderful mineralization, you have low losses, where you may be able to get by applying 7/10, 8/10, whatever, depending on your soil types, in order to reach that yield goal. But again, we know that it takes 1.1 pounds to grow that bushel of corn. It's how much do we have to apply to get there. And that's really one of the goals of what we're trying to do. You'd be surprised at the data of what percent of nitrogen is applied actually gets taken up by the plant every year, and it's lower than you think. And that's really our goal, is to be more efficient, to reduce our losses by split applying, by understanding what's going on in the field, and then be more efficient. Jim?
Yeah, I just wanted to add one thing, because you're right, Jim. Both Greg and I try to get to about 0.7 pounds applied to bushel produced. But I think one of the key things that helps us do that is the timing of our side dress application, because we're putting it on when the plant is going to take it up very, very quickly. And secondly, it's the placement.
Yep.
So we're getting a better efficiency of uptake. So a lot of that nitrogen that's out in the center of the row never gets taken up.
Yep.
So it's intuitive that you're going to get a better NUE just because of the placement with the wide route.
Yep. So great question. There was another question, and I'll tell you what, it was about applying hog manure in the fall. I'll tell you what, call me, email me, and let's have a conversation. That is a long conversation. It's a great question, but in deference to time here, I think we're about ready to wrap up. So, Kevin, call me. I'd be happy to have that conversation. So, John, are you wrapping up?
Well, thank you for joining us this morning. We had a nice attendance. Please send us some feedback on the best time to host these. We'd like to do at least an every other week webinar, so we want to get those kind of scheduled and make it a habit for you to join us on these conversations. We've got a great team of agronomists here that have a lot of knowledge to share. So we also want to know what topics you'd really like for us to cover and dig in. So if there was something here that you liked, but you'd like to dig in deeper, this is the forum for that. So send us those notes and suggestions, and we really appreciate your time today. Go out and have a great day.
Hey, one other quick comment. Sorry, I misspoke. That solution, the pH nitrate solution, is $36 a bottle. Is that right?
Yeah, that's correct. And just one thing on that, because there were a few questions. If you don't have a pH sensor and you have the old solution from last year, if it's been sealed up, that's fine to use if you don't have the pH sensor. Right. But we are going to move all of our solution just so we stock one solution. It will be the pH and nitrate. So that's okay to use too. So you can use either one for nitrate. If you have a pH sensor, you have to be sure and get the new solution. So I hope that makes sense.
All right.
Very good. Thank you very much.